It's 2026 and AI agents are everywhere. They usually work until they don't. So last time we built an AI agent using LangChain, and this time we're gonna add middlewares to it. So let's get to it. So this is a super basic AI agent that we discussed in the last video. So now we'll be adding middlewares to it, and let me explain how it looks like. So this is the component diagram with the middlewares. So if you see, there's the same architecture, same components, but we just see these two boxes here. These are called middleware hooks, which is given by LangChain. A middleware hook that is between an input and an LLM, that means it's a before hook, and any hooks that are after the LLM processing and before the output is generated, it's called the after hooks. So the before hook represent any processing that you want to do before your request reaches the LLM. So that could be basically anything. Let's say I'm building an agent which like does currency conversion or something like that, and before doing anything, you want to convert all the currency inputs to like let's say USD before even hitting the LLM. So you can write a before hook where when a user enters any currency, then it just converts into a USD and then passes to LLM. That's just a basic example, but anything that your query needs to get processed with before your input reaching to the LLM, you can add in the before hook. And any pre-processing that you need to do after the LLM has processed your request, but before the user sees it, you can add it to the after hook. So now let's get back to the notebook. So what we have here is a banking assistant agent, which I've just created like a mock. You see it has two tools, which is check balance and transfer funds. Check balance takes an account number as input and produces the balance as output, which is like hard coded to mock it. And there's a second tool, which is like transfer funds, which can transfer funds from one account to the other, and it takes in an amount and a memo as input, and then it returns I've transferred this amount from this to this with this memo. So this is like very super basic mock agent that will help you with the banking. So let's run this, and okay, so this got created, and let's say we want to create a banking agent, and let me also print how the agent looks like. Okay. And as you can see, it's a very basic agent which has a model and access to these tools, and it can interact with it. So if you invoke this agent, I'm using like two messages, like what is the balance of the account, whatever, and print that. And the second is, can you transfer $10,000 from account this to this? Like that's just two messages. So let's just run this. Oh, I think I missed adding print statements here. So it's not printing the first one. So let me quickly add that respond.messages, and this will still print. So I'll rerun this. Okay. So this is like the first question, what is the balance of this account? And like it just responded with, yeah, so it responded with the balance of this is like this, like we said. And then the second query was, can you transfer $10,000 from this to this account? And as you can see, this was the input. And then this, it says the transfer of $10,000 is successfully completed. So now let's say our original intention was to only transfer $1,000, but we did transfer $10,000, and agent just executed the action, right? And now it's a critical issue. So this represents any critical action that any agent can take. This is just a mock scenario, but it represents any action that agent can take that can cause serious issues if it goes bad. Like this is just one example. Let's say it hallucinated and transferred like $100,000. So this is kind of risky. Things like these need like human approval. They should need human approval. Models are not that amazing or that capable yet that they don't hallucinate or can distinguish between something good or very critical. So this is where I want to introduce human in the loop middleware. So as we can see, like it lets a human oversight to agent tool calls. So basically you can say, okay, before you make a transfer, check with a human that for approval. So let me explain you that with an example. So this is my new agent. which I'm naming like banking agent human in the loop. What it does is the same model, same tools, and same system prompt. What I've added here is the middleware. So I've defined use human in the loop middleware and interrupt me when I use transfer funds tool, and this tool string matches the function name of transfer funds here, right? And what we're saying is only allowed decisions when you interrupt is approve, edit, or reject. So what it will do is it will get interrupted when transfer funds is initiated, and it will expect a user to input like an approve or an edit or a reject. So it won't execute the transaction. And for the check balance, we don't need any interrupt. So we just made it to false. Like people should be able to check their balance without any interruption. So that's that. So let's run this agent. So now if you see, this is our improved diagram now, right? So we had the start, the model, the tools. Now we have a middleware right here, which sits between the model and the tools, where it says human in the loop middleware. So let's go ahead and see this in action, right? So we define a config, and we are saying there's a thread ID, which is a unique ID. So thread ID means like a conversation ID, you know, like in ChatGPT, when I click on a new chat, it's like a new thread for me. And then you can talk to an agent within the same thread. It'll keep context of the same thread. And the way it keeps the context is using memory. So if you noticed here, I had a check pointer in memory saver. So what it does is for every unique thread, it will save the context in this in memory check pointer. So that's why we created a new unique thread so that it doesn't get mixed up. So this is a very fresh thread it will create. So now what we'll do is we'll call this agent invoke, and we'll just say transfer $10,000 from this to this. This was the first, the same query that we did before, and we're passing this config to this. Now we'll see what the initial response, which should be interrupted, what that is, and then we'll see what if the interrupt is there in the response, then we're seeing interrupt detected. So let's run this. So now if you see, initial response should be interrupted, and it says interrupted, right? So basically it is now interrupted and it requires human approval. So now in the next cell, what we're doing is if interrupt is in response, which is true here, now we are commanding the agent that this is my command, resume with my decision of type approve. And this is the same approve which we defined up right here. So what we are saying is this is my command, which is resume based on the decision, which is approval. And now the same configs to maintain the same thread ID. And now let's see what happens. Now it says approving the action, which is just a print statement. So nothing exciting there. But now let's see the result after approval. So now result is like the human message is to transfer, and let us scroll here. The AI message, which is here, it just says the transfer of $10,000 from account is now completed. Basically, it was interrupted. It was expecting an approve, and only then it executed. So now, what if we want to like reject it, right? So the same stuff. So now I have a new thread ID. I'm saying transfer $500,000. This is insanely big amount. So now what I'm saying is, okay, interrupt this and reject my decision, and let's see what the LLM does. So it should reject it. So let's run this. It's running. See, my initial response is like it got interrupted, and now we are saying we are trying to reject it. So this gets printed out, and this is the result after rejection. So let's see. Human message was still to transfer the amount. So we'll have to scroll to the right. Okay. So this is the AI message. It says it seems that the transfer operation has been rejected, and blah 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 blah. So basically, now we said reject, so it did not execute the transaction. So let's see an example of the edit as well. Let's say we want to transfer the same amount, but the account number is wrong, or the amount is wrong. So let's see what happens in that case. So this is like $100K from this account to this account, and then we say okay, interrupted. If it's interrupted, then you fixing the problem. And now this is pretty interesting. So look at this. So now we are saying once the interrupt happens, resume the execution based on the decision edit. The edited action is on the tool transfer funds. The new arguments, which are corrected ones, is the new account number from 2, and now instead of 500, sorry, whatever that was, 100,000, we only want to transfer $5,000. And this was the memo. So now let's run this and see what happens. So it's running. Okay. So it says last transfer detected interrupted, that we know. And now we go and see the AI message again. Yes, I have successfully transferred $5,000 from account this to this. So it edited the original request and then it executed after we edited it. So basically, original one was 100K and now it only transferred $5,000. So this is how the edit functionality works. So this can be used in like various use cases, and that's where human in the loop comes in. Now let me explain you how it works with the streaming, because streaming is the way to go for agents. So when we query the agent with the stream, so we iterate over each chunk. For each chunk, what we are trying to figure out is if the mode is updates or the mode is messages. So updates mode means when the agent is making an update and it's not like an message, like an AI message coming back from the agent. So in terms of updates, so when the mode is updates, we check if it's an interrupt. If there is an interrupt in that chunk, because there are many chunks which can have updates but not have interrupt, then we say interrupt is detected. So we print that out. And if it's just messages, then it's basically a normal message. So we just printing the token, like whatever message it produced. And now what we're saying is, so this will be interrupted. And the second part, okay, let me first run this. So it says streaming a dangerous thing, transferring something, and it got interrupted, right? So now we want to reject it. So what we'll do is, again, call the same with the stream for each mode and chunk. We are saying the command should be resume based on the type reject, and passing the same config. In the stream mode is again updates and messages. If there is messages, then just print that. So now we don't have to read the update because it will not get interrupted. It will just reject it. So let's run this. So if you see, it says user rejected the tool. So the transfer is rejected. So this is how you use human in the loop in an agent. And this is pretty critical for the use cases where the action has very large impact. As we know, LLMs still hallucinate quite a bit, and they are not fully reliable. In the end, they are machine learning models. They are a prediction engine. They are non-deterministic. While the research and everything is happening really nicely, and they're getting more accurate, but the bigger the model is, the chance for hallucination also rises. And that's where the human in the loop middleware really shines. It gives control to the human and prevents the AI to go bad. That's it for this video. Hope you guys like it. The next videos would be around summarization middleware, memory, deep agents. And as you guys know, I'm also learning this stuff. So yeah, let's build together and learn together.